It's going to take 1 minute or two. Okay, so while waiting for Soufian to join the talk, so today we have chosen to talk about the sovereign inference at the lower TCO. I mean, we are in a stage today where we're past the stage of testing, and now we are more in a stage of production. And the difference between the two is we're at the first stage where we are testing and building the GenAI platform or the GenAI solutions. What we are doing is basically we are testing the models, testing the technology, and testing the whole idea of like building generative AI. But now we are at a stage where we want to deploy this technology and make it useful in production. And once we are there, the problems that we face at this stage of development are very different from the problems that we face in productions. And because now we are talking about problems of scalability, problems of data sovereignty, and problems of cost. And those are some of the questions that we're trying to answer today or solve today. And our guest is someone who works in the chip side or in the deployment side. I'm not going to say more about the guest. I'm going to let him introduce the whole technology. But basically, what I'm trying to say here is we are going to cover the critical side, because if you notice, or if you are working in any IT sector, what happens is, any idea that you're trying to adapt, even if it sounds cool, the fact that you want to put it in production and while sticking to all the regulations that you have in place may not be an easy task. That's why there are so many questions that are raised. And I think we have finally Soufian here. Just going to give him a couple of seconds to see if he's able to.
Can you hear me?
I can hear, but I can see you.
One moment. Let me fix this. Can you see me now? Okay.
Yeah. Hi. So how are you going to make it up for us? Let's talk about it after the podcast, right? Yeah. How's it going, man?
Good. Busy day. I think it's late in Dubai, but
just for the records, I think it's 10 p.m. your time, and you just had a couple of meetings, and you're joining now another meeting. So thank you very much we appreciate the time and the efforts that you're doing there. Yeah, I have spoken a little bit about like what we are going to talk about, and I introduced the subject, but I'm gonna let you do this afterwards. But I got a joke for you before we start this. So before going, I was thinking about our introduction on how I can introduce the subject, and I was like, "Do you watch Joe Rogan, the podcast?" So what he does lately is basically they just keep the cameras rolling, and whenever they have a guest, they start talking, and when the guest asks, "Are we rolling?" he just says yes, and the conversation goes naturally. But we cannot do this because of technical problems. And I thought about the second joke, which is we're so cold now because we cannot afford the electricity to heat ourselves, because you're building data centers that make the electricity expensive.
Actually, the nice thing about SambaNova is we are really energy friendly, and I think this is one of the things we're trying to solve in the data center business is that we wanted to be very energy efficient, meaning that you don't have to build a nuclear power plant or any standalone power plant just to power your data center. The idea is to be very efficient.
Hold on, I gotta cut you off with this. You mentioned SambaNova, you mentioned a lot of things. How about you introduce yourself and introduce who you
Yeah,
are
sure.
and what you do?
Uh, Yeah, so hi everyone. So my name is Soufian, and I am principal AI solutions engineer at SambaNova. So just a little bit of background. I've been working as a data scientist and also in the AI field like in the past 8 years. So I finished my studies, engineering studies in Morocco, École Mohammadi des Ingénieurs. Of course, I did les classes préparatoires. And then, of course, I did some studies in the US for AI in medical and bioinformatics. So I get a little bit of background in consulting. So just after my second master in the US, I joined a Bain& Company, where I get the chance to basically work in the whole Europe. So I worked in Zurich, Copenhagen, Germany with a lot of banks and retail companies, and also I worked in the Middle East for Saudi and UAE and Qatar. So right now I joined SambaNova. So it attracts me a lot with their innovative solution. We hear a lot about ChatGPT moment, and suddenly we got a lot of tractions about building a lot of data centers because these models really consume a lot of things. So I'm happy. I think in the next couple of minutes we can talk about the company profile for SambaNova, how did it start, etc. I think this is a little bit of background about me.
Yeah, sure. Thank you very much and congratulations in your career. We're gonna go back to your consulting career and why you switched to AI. But before, can you tell us about what you do at SambaNova and what is your business model?
Yeah, sure. So I think just as a a background for SambaNova, we started in 2017. It was a spin-out from Stanford University by a group of researchers who came from the idea that right now the way how NVIDIA is handling the AI workload is completely different, and it's very inefficient. When I say inefficient, it's not fast enough. It's consuming more energy than it should be, and also the number of hardware needed to be able to handle those large language models. It's just it could be lower. We can compress the hardware instead of using 10 racks of NVIDIA. We can use much fewer racks in order to host those LLMs with a fast speed and performance. So we got a little bit like a little bit of traction in the beginning, and the traction starts even increase after the OpenAI and ChatGPT moment. We received more than 1 billion in funding. So the funding is coming from a very serious investor like BlackRock, Google Ventures, Intel, Samsung, Google, etc. Google Ventures, I said again, and I think that just came from like really the confidence we get from these people. These people really get access to our technology. They understand how it works, etc., and they really bet on it. And they're not people who are just from the investment side. They are also from the industry itself. So the chairman of Intel is our the CEO of Intel is our chairman, which is name Libutan, and he's really well known in the industry, and he has like a huge belief in SambaNova potential. So yeah.
You started by trashing NVIDIA. So what? But
To be correct, we're not touching NVIDIA. I think NVIDIA is really an amazing. It's really an amazing company. I'm not just here trying to just throw in flowers, but the idea is like there's certain AI workload that we can do much better than how the typical way how we are doing it. And I think NVIDIA is amazing for training, but right now the industry is moving to inference. Right now, a lot of companies are not interested a lot in training and like building LLMs from scratch. If you want to do this, I think you just can go and do it with NVIDIA. But I think right now the most of like the big part of the market is going toward inferencing, and inferencing is not And here we're gonna start talking about this.
So this is what I was going to say. I was going to go back to the question why Intel chairman would invest or would go and be investing in your company while they can build the same thing on Intel. But this is some question that we're gonna leave for later on, because we need first of all to define the title that we have used today. We're saying sovereign inference at lower TCO. So I think the first thing that we need to start with is what is inference and why are we talking today about inference? And what I want you to do is to explain to us why. There are two stages or two main usage of the models. We have like the training stage and then the inference stage, and the why or why are you focusing on the inference side? And aren't you like also working on the on the?
I just wanna. I think I want. It's good to give a little bit of introductions for like what SambaNova is capable to do, and then I think the picture will be like much more clear. Can you see the screen?
No, it's not shared yet. Now I can edit the stage, and here we are. Yeah, go ahead. Your stage is yours.
So I think the first question, I think you asked me first question is why, for example, we need to go for inferencing. And I think this is just show you like the growing demand for inferencing. A lot of companies, they are not actually very interested in training their own LLMs, but they want to do is they actually want to use those like open source LLMs. And if you go to Open Router, for example, and it's an open public data, that you can see the demand for inferencing is really huge. So we're talking about trillions of tokens per day, like consumed by different LLM inference providers. I think for the data centers and power constraints is like these data centers are first of all are very old, and also they are basically using very typical data powers. If you want to do GPUs, etc., you will require like a very exceptional power supply, and it's not possible for a lot of the data centers, especially in Europe. What I wanna go very straight and I can show you here is like this is just what does it mean to use SambaNova versus NVIDIA. We have higher memory, we have a better architecture that allow us basically to really run those LLMs in a very optimized way. Like I'm talking about like here, like we're talking about like 5 times, 6 times, even sometimes 20 times the speed and the throughput and the productivity of one rack versus from SambaNova versus NVIDIA.
So when you're saying 5 times compared to what? What's your base comparison?
So it's a number of tokens you can produce per user per the unit of power you generate. So how much power you need to, let's say if we are consuming 1 kilowatt, how much tokens and how much basically you can produce with one hardware of NVIDIA compared to SambaNova. So if we took, for example, Llama Maverick, we can do 2,000, almost 300,000 tokens per second for 1 kilowatt consumed versus 5,000 kilowatts per second on NVIDIA per one power unit that's being used.
Okay, that's huge.
So I think what we want to basically communicate here is, and I'm going to basically give you a very nice announcement we've done in Europe. And Europe has really power consumption is really a big thing for them. We you cannot imagine doing NVIDIA with renewable energy. Like Jensen literally asking his customers to basically I don't know, doing a nuclear basically power plant in order to power those data centers. I think for us, we are very energy friendly, if I can say so. We only require like 10 kilowatts per rack in order to generate those to make them operational. And this time, I think this week we just announced a very huge AI inference provider in Europe called Argyle. And Argyle, they are actually powering their own data centers using basically renewable energies. as I said, it's something very differentiated compared to NVIDIA. But yeah.
Okay, so if we want to take roles here, so imagine that I'm an AI engineer who works for a company that wants to deploy their AI products. So imagine that I've been working on the development side, and now I am ready to deploy my agents. I have tested and everything, and I have convinced my bosses. And now the first question that comes is, what is your procedure and what I should do? So I want you to give me, for example, what are the stages or the steps that I need to take in order for me to take my development products and put them into production.
Look,
and how are you going to help me with this?
So I think from there are different way how you want to see this. Do you want to see this as from a provider point of view, or also from a developer point of view? So from a developer point of view, there are actually answer for both. But yeah, tell me which one do you want to start with? I'm happy.
So I want you to see it from a stakeholder point of views. So imagine that I wanted to convince my boss to invest in that product, and I want to convince them that I'm going to be compliant with the regulations. Let's say I'm based in France, and they want to say that I'm compliant with the regulations, I'm energy efficient, and my product is scalable.
Yeah, that's a good question. So I think the first there are many ways how we can discuss it. First of all, like of course, I assume you have a data center already where you have like your own data. We are already running some sovereign infrastructure, like your own. Let's say you are a bank, and you have your own data, like data center that is actually storing your data, storing your basically also infrastructure, compute. I think you have a little bit of compute. So the first thing is, if you want to do NVIDIA, you will maybe very likely, if you want to use something with high performance, you need liquid cooling, etc. For SambaNova, we only require like air cooling, typical 10 kilowatt power supply, and that's it. So if you have enough networking, if you have enough like a very typical data, very typical power supply, you'll be able to operate this. So the ease to operate and integrate our hardware is very different, because let me tell you this: if you want to do this with NVIDIA, you need to make sure you have the necessary engineers who should be able to operate it. There are so many data centers who bought those hardware and they have no idea how to scale them, like even to get them to run and to use those NMs, let alone to basically scale them on maybe hundreds or thousands of users. So for us as SambaNova, we not only offer the hardware, but also we offer the software on the top of it. So you can literally, we have a product called Samba Managed. We allow customers with no talent, like if you don't have any team of AI, any team of hardware, you can literally go from zero to productions in 3 months, in 90 days. Meaning that you will have your infrastructure shipped, installed, ready to go in 90 days, and be operational on sovereign. It can be air gapped, it can be connected, whatever you prefer. So to recap here is it can be like if you put the same. I'm not going to talk here about the pricing, but let's assume it's the same pricing as you're going to spend on NVIDIA. If you want to do this with NVIDIA, you need to make sure you have the right team. You need to make sure you know how to operate it. You have the right infrastructure, like the cooling, the power supply, etc. For us as SambaNova, I don't have to worry about any of this. If you have very typical network and very typical power supply, you'll be able to be operational in 3 months, which is not something that actually exists. It's very exceptional, by the way, in the markets.
Yeah, so let's assume that we're not talking about any provider, and we just want to deploy our model. So how does it go? How does it go technically? Say, for example, that I need to run Mistral, and I have in mind the number of tokens that I need per second. How would you go about like giving me the right infrastructure that would respond or would meet my needs?
So of course, I think there are like we allow two things. So they are like the leading open source models, and I can show you basically here. I can share my screen.
Please go ahead.
Yeah. So You can see here our screen. This is our cloud portal. I just give you
we don't see your screen a lot. It's there.
Yeah. So I think this is our cloud portal, and the purpose for this is just to give our like developers and also for our customers the feel of what is it like to run and use SambaNova hardware. So this cloud that you see here is sitting on multiple nodes of SambaNova. And you can see here like the models we are basically supporting. So it goes, and you can see here like those are the most leading LLM customer, like LLM open source models. We're talking about DeepSeek, GPT-OSS, DeepSeek V3, DeepSeek Terminus, which is like been released recently. And also we have the multimodal LLMs like Llama, Maverick. We have Whisper for transcription, etc. I think let's assume you got your racks installed on your data center. The only thing you care about is just this interface. When I see this is like you just need to provision the API key and provision the URL that will be custom to your data center, and you should be able to operate it just typically the same way as you are doing with OpenAI endpoint or any other endpoint you're talking about.
Okay, so basically this is the like the cloud solution. To say that I'm gonna.
But the thing is, you can get exactly the same experience on sovereign installation. It's gonna be exactly the same.
So just to clear things up, what happens in the cloud is I'm sending you my data, inference it within your hardware that you have on your cloud, and then you send it back to me.
Exactly.
And how do you go about this for Europe? Do you have like your own data centers here? Do you use like the hyperscalers?
Look, I think for it's not like I think we have right now like our racks in Europe, and we use AWS as hyperscalers, but I think it's mostly in the US. But we also have our own data centers. If you want to do, for example, inference in Europe, it's actually very possible. And we have this one right now in Germany, and I think we have also one in the UK and Scotland. And also very soon in other European countries. You should be able just to, if you want to go with the cloud, just subscription, you can go and do it. But also we allow you to have your own dedicated node, your own hardware that you can run your own LLMs on it, which will allow you to host multiple LLMs at the same time.
Yeah. So if we want to split the possible solutions, we have like to have your own hardware, to have the hardware on the cloud, and then the third solution is what do you call it, the hybrid one?
Yeah, I think the hybrid one for us right now, it's basically you can either go to the cloud, or basically you have your own dedicated node hosted on your own data center. Maybe the hybrid one is you have a dedicated node, but it's hosted on our data center.
Okay. Yeah. So in here, are you basically saying that you can either be a hardware or software provider in this way?
Yeah, actually, good points. I think the idea for a lot of hardware companies, if you are a hardware company, you have no other choice but also to develop a software on the top of it. And let's take the example of AMD. I think AMD is a hardware company, but if you check it in the history of their operations, is one of the main bottleneck for them as a hardware company is that their software is very bad. Like it's the compiler and the software that actually operate the hardware, which is a medium, like a intermediary layer that operate the application layer and the hardware. So software is definitely an important component for any hardware company, and this is something we are providing our customers with. Just it's also part of differentiation. Like we really make it easy for our customers to use the hardware compared to just here the hardware for NVIDIA or any GPUs or any other TPU or etc. Just go ahead and just operate it by yourself. We just literally give you the software and the hardware together, and you don't have to worry about operating it. You just have to worry about actually making the best out of it. Like either sell that capacity to other customers or either make it actually useful for you inside the company.
Okay, so I'm going to go back and take it step by step. So the first thing that we have established is the service offering that you have. You have a software provider providing the service, and you have also a hardware one. You can choose between the one, and let's assume that I have chosen to go with the hardware solution, and I want to host it on my own data center. Now, there are two questions that comes with this. So, what do I need to provide you with? So let's say, for example, we're not talking about Mistral, we're not talking about any known open source models. We are talking about something that I have developed in-house.
Okay.
So what do you expect me to give you? And the second one is, how are you going to buy the hardware? Or what are you exactly going to do after this?
Yeah, good question. So look, I think for us, we can support any transformer-based LLM. So that we are technically capable to support any type of LLMs or any type of AI models. We can really support them. But the idea for us, and again, for the software perspective, we are focused on making sure that we make it easy for our customers to host their LLMs. For now, it's mostly available for enterprise because it's really huge in capital investment. I think, let's say example, if you want to go with NVIDIA.
Do you have any numbers?
So, look, I think let me just give you some public numbers.
Okay, go ahead.
I can give you some public numbers for NVIDIA. If you want to buy like H200, or you need at least $500,000 to be able to acquire that H200 in your data center. And we're just talking about the hardware. We're not talking about the software. We're not talking about the power supply. We're not talking about a lot of other details. So the idea for us is this is the type of hardware, like it's very enterprise grade, that allow our customers basically to go and take them, host them in their own data center and operate them. And by the way, this is very known in the data center industry. This is a little bit like mostly by the banks. They can make a decision to buy their own infrastructure, etc. So the idea is, okay, the moment you have your hardware on your data centers, we actually allow you to do two things. You have your own LLM. We allow you and we assist you basically to host it on our own hardware.
I'm just gonna so that we understand better. When you say I have my own LLM, so I have the weights and biases. Is this matters that I want to give you? What exactly you expect from me to give you?
Yes, you give us the weight. You give us the weight basically that of that model, that LLM that you just train it on GPUs. You'll be able to host them on SambaNova. I just want to add a little bit of caveat here is that that the thing is with SambaNova is we have like very specific LLMs. So if you go to Hugging Face, like 1 million LLM that you can actually use. In order for us, while we technically support any LLM, we are focusing on specific LLM leading in terms of performance and intelligence, etc., and popularity in the open source community. We're trying to make them really as fast as possible and optimized as possible. So while you can actually bring your own model, this is something we are open to discuss. But also what really is in the market is customers, what they say, they take Llama 7TB, they fine tune it on their own data, and they start using it. And this is something differently we support. We allow our customers, we tell them, bring your own checkpoint, which is a feature in SambaNova, is that you can bring your own checkpoint, which is the weight and biases that you can bring in, and you can host them on SambaNova.
Okay, great. And how does it go? So where do you get your chips from, knowing that you have a big competitor like NVIDIA who are ready to pay millions dollars for your chips?
Yeah, I think it's a very typical process for as many other companies. So we do the design in what is it called? Like in California, in Silicon Valley, in our HQ, and we do the manufacturing in Taiwan, and of course the assembly and everything else is done in the US.
Okay, great. So once I have my model trained and now I want to put into production, I get in touch with you and you give me a proposal that I accept, then what's next? Is there a wait? Is there a wait list? Is there a time between the...
Actually, this is one of the nice things about SambaNova is differently from our customers. They have a little bit of supply chain issues. You have to wait like 8 months let's say. Typically like 6 months for the leader of the market like Nvidia. I think for us you can really get so imagine 6 months just to get your hardware delivered to you, maybe additional 6 months to make it run, or maybe a year before you make it actually operational. So we are talking about at least 1 year. For us, the moment our customers place the orders, they really get in 6 months, they are already in productions. You are already having that hardware. By the way, we do it like way less. As I told you, in what we promise is 3 months lead time for Samba managed. You can really start already operating and using those LLMs and have them in production environments.
Okay, great. Now that I have, let's say that we're past the 3 months, and who installs the hardware? Is it you?
Yeah, we have our team. Yeah, we have our team basically who does that.
Okay.
And it's always a collaboration with, like, of course we collaborate with our customers, with their team, etc. But it's on us basically to do the installations and everything.
Okay, so basically your team comes in and installs the thing. How do you connect it to the existing infrastructure? How can I get access to this? Or what is the control plane? Is there a control plane that I have access to?
Yeah. So what we do is once we bring up the software on the top of the hardware, we just expose an endpoint. So it's depend up to the customer. You can connect through a VPN or through the local network, and you'll be able to access that endpoint, or you can even actually expose it to the public, and you can actually go ping it just exactly like you're doing with the OpenAI endpoint, and that's it. It's this simple. Like literally, you don't have to worry about like mapping the LLM, doing the model surgery. You don't have to really do the orchestration of different LLMs running together at the same rack or the same environment, etc. Everything is actually handled by SambaNova. You just
so there's like an abstraction layer that you put on top of the hardware, and the abstraction layer is basically a control plane where I can come in and I can deploy basically in a model that I want. So I'm not like limited to the model that we have promised at the beginning. I can change it. I can do whatever I want. I can upload a new model.
Of course. Look, I think, as I told you, you'll be able to bring your own fine-tuned LLMs from the leading. We provide our customers with leading LLMs that we support. It's a huge list. But what we promise for all the customers is that you will be able to find all those LLMs that you are using on the daily life, like let's say Quinn, we're talking about DeepSeek, we're talking about Llama, we're talking Llama Maverick, Whisper. All these are actually available. So you'll be able actually to get all these models, bring up to you on the hardware, and you can deploy anyone that you want, basically on the SambaNova.
And are there like updates? Or I have two questions. Where do you store the models? Are they stored locally, or there's like a connection to the internet, or how does it go?
We do a regular update to our software, so definitely you'll be able to. So, and also the list of the LLMs is not something that's static. So every time there is actually new models, we support it and we make it available for all our customers, basically, to be able to do it.
So when you say we support it, you're not doing much. You're just basically installing it or somehow.
So look, I think this is a good question, because when you are doing hardware, there's also a compiler layer, which is like for NVIDIA, it's called CUDA. For SambaNova, it's called SambaFlow. So there's always like this conversion between. So let me give you an example. If you have something running on CPUs, you cannot just go ahead and run it on GPUs. If you remember Apple, when they come up with their own chip, there was Apple Intel and there was Apple M chips, basically. And there were like a lot of software don't work the same way on Intel, and they don't work the same way on M chips. It's just a typical issue with any type of hardware. If you're moving to CPU to GPU, the execution style will change. And so it's the same case for SambaNova. So what we do is we take the LLM that you've been training on GPUs, we just do what we call model surgery and make it available on our RDUs. We just like do a little bit of change, because this is exactly what makes it different for us. Like we have our own different way of execution that allow us to make it run faster and much more efficiently than NVIDIA.
So basically, you're taking something that is trained on or was done for CUDA, and you basically are adapting it so that it can be compatible with your chips, which Okay. So does that apply also on something that I build on my own? If I build something that is compatible with code, do I need your intervention so that I can make it more compatible with the solution?
I think one thing we're offering to our customers is to be able to do this process automatically without
Cool.
actually needing to do any engineering support. So that's basically our way how we are trying to support our customers for this.
Okay. Do you want to answer that or?
How do you see companies like CoreWave helping with TCO? I think CoreWave I know they are very specialized in GPUs.
Who are they, by the way? I do not know the company. What do they do?
So CoreWave, I think, and we can actually look it up in the internet. The thing is, CoreWave is like just like a lot of other companies who are trying to optimize the GPUs installations and infrastructure. So they're like other companies doing the same thing, like Fireworks, Together AI, InScale, all these companies, and they're not tied to NVIDIA. Actually, they're just trying to. So there's NVIDIA who build the chips. There are other companies who really squeeze the performance out of those chips and trying to do a lot of CUDA programming to be able to make it really fast and efficient.
Mm-hmm.
And of course, this will impact the TCO. I think they are like really doing a good job, but I think our line of business is completely different because we are not talking just about the compiler level. We're talking about the whole thing. So yeah, you can maybe change the optimization and the speed, but you cannot change the power consumption. You cannot change the hardware footprint because, for example, let me give you an example like DeepSeek. If you want to do it on NVIDIA, you need at least like really just to make it run like 2 nodes of H200 or H100. For us, we do it with 1 node. And if you want to run it with a very large, with very like a big speed, we're talking about 50 tokens per second, 80 tokens per second, you need a lot more than that. So DeepSeek, when they released the paper, they said like they needed 40 GPUs to be able to do it. At SambaNova, we were able to run DeepSeek with only 1 rack, 16 GPUs, 16 RDUs. And we do it like while NVIDIA can do it with 40 tokens per second, we were actually doing it with 200 tokens per second. So here we're talking about like 5 times the speed. And this is really a huge difference.
Okay, so up until now, we are only talking about inference, right? We did not talk about
inference.
Okay. Yeah. I think another use case that you have is the refinement of the model or the fine tuning of the model. Do you see any difference, or do you see any added value of the optimization that you have done with this substitution of the chip?
Okay, look, I think for when we are talking about training, which is fine tuning, is part of it.
Mm-hmm.
So training and fine tuning is very different.
Do you want to explain the difference between training and fine tuning?
Yeah, exactly. So if you go to so training is something we call in the hardware like it's a compute heavy and compute full. Inference is more about data heavy, like data movement focus. Let me tell you this. So in hardware industry, there is a very famous problem called the memory wall. So when you are doing the training, let's imagine like a feed forward layer network. So you have input layer, the hidden layers like one after one after one. You do the calculations and then you go to the output layer, right?
Yeah.
So the way how NVIDIA does it is I'm going with the input layer. I'm going to the next layer. I'm going to upload the random layers, the random weight. I'm going to do the calculation for the whole training data or maybe the whole batch. Okay. So I do the training for the whole batch. Wait until the calculation is done. I upload the weight and put the new weight of the new layer, the next layer, etc. So it's uploading the data. So it's something that we call kernel by kernel execution. So it's like a blocks it's single instruction, multiple data. So one instruction that's running actually in parallel on multiple data, subset of data. Once that calculation is done, we offload it from the memory and we move to the next block, and we do this repetitively. The problem with this is very compute heavy. This is how the training is happening. So it's very compute heavy. The movement of the data is not really that critical as much as the calculation of the weights and the update of the weight is very important because we are doing the training. For the inferencing, it's actually not the case, because inferencing, you need to move the model of the weight, weight of the model and the KV cache. The KV cache, but this is basically the whole thing, is the model weight and also the context, etc. And the inference, what it's happening is like you're doing the prediction of the next token. So when you predict the next token, you add it to the KV cache. You run it through the memory, and you do this again. This is how you do the generation. So this is memory. This is what happens. We call the memory wall, because moving the data back and forth, it's going to be really, really a significant process to do. And this is not a compute heavy. It's not really intensive in terms of compute, but it's very intensive in terms of the data movement. So that's why at SambaNova, we are really focused on optimizing the inference workload and profile, rather than trying to focus on the training. We can do the training, we can do the fine tuning. This is something we do for our customers. By the way, companies like Aramco, they give us all their data. Imagine how sensitive is Aramco, like the largest oil and gas company in the world. And they have it's a sovereign company. They have their own data. They want to build their own LLM. So they came to SambaNova, and they know other providers, and we help them save the energy to do the training. Of course, there is a saving in terms of energy, etc. But really, the value of SambaNova is not only when you train that LLM or you do the fine tuning, actually when you are doing the inferencing. So when you are doing the inferencing, you're going to save a lot of money and a lot of actually costs for that. Let's take the example for OpenAI. I think you've heard in the news that they're talking about like they're really having a hard time making money out of ChatGPT, because he said, thanks and please really make us really pay more money than we should, just because the inferencing cost is really expensive in terms of energy, because the electricity bill at the end of the month you have to, or the end of the year, you have to really pay very high. So this is the things we're trying to focus on. So we give you very 5 times, 6 times, sometimes even 20 times faster than NVIDIA, with very lower energy consumption, and with very little or maybe fewer hardware footprint to be able to do it. So,
okay. So if we stick to the energy side of the task, if I take, I'm just thinking about the GPU, the normal, the gaming one. If I take it the compute's part, and the memory part is a small one, and the whole thing is just for cooling the hardware underneath it. So I think this is the cooling is the bottleneck of the chip. For you, for example, is the same thing, or you're choosing the whole thing? You do not need. How are you doing the cooling in the first place? And like what is it? How are you different than this approach?
Okay, so let's be able to understand the cooling. We need to understand what really caused the heating of the servers. And of course, we're not just using those gaming card. It's actually a whole, like it's almost how much? Like 600. It's like 600 kilograms.
Yeah, I just used the analogy of the gaming because it would speak to a lot of people.
The idea for why you need cooling, because the system is getting very, very hot, right? Why it's actually getting very hot, and this is very interesting from hardware perspective, is the more like you have the compute memory, and you also have the HBM, or the high bandwidth memory. So as I told you, when you are doing the calculation for the layer, you need to offload those weights and go to the next layer and upload the weights. So you are moving data from the compute memory between the compute memory and HBM, the high bandwidth memory. So the trajectory or the route from here, the more you move your data, the more energy you're gonna generate, because this is electricity. This electron moving and doing a lot of resistance in the wires, etc., and it's just a lot of electrical engineering stuff. Is like you're really causing a lot of energy, a lot of heat. There is actually the more, because you have
a lot of friction.
Exactly. So you have to move your data a lot. For SambaNova, the trajectory to move between HBM, the compute memory, and the HBM is just very small. So you don't have to really, the data doesn't have to travel much. And also we have higher capacity. So we move the data the frequency of moving the data is very little compared to NVIDIA. Because if you can do 8 gigabytes of compute memory, it's not like if you have 500 megabytes. So the frequency to move the data between HBM and the compute is very low, and also the distance between the HBM and the compute memory is very smaller. And you can tell me just NVIDIA can just do the same thing. They can just make it closer. That's not how it works. It's all about the compiler architecture. So if they want to change this, they have to change the whole architecture and the design of CODA. So let's go back to the heating problem. So because you are moving the data, the frequency to move the data between the compute memory and the HBM is very small, and the trajectory is actually shorter. You're not generating as much heat as NVIDIA is typically doing. So for us, we just use the typical cooling system. So any data centers, there is actually a worldwide front end and back end cooling systems in most of the data centers. We literally need only that. We don't have to really use any exceptional cooling system to be able to operate SambaNova. For the same workload, let's take for DeepSeek, you actually sometimes, if you're using Blackwell, you need actually liquid cooling, which is another drama to work with and to deal with. But for us, really don't have to worry about any of that.
Yeah, so I've been watching a video yesterday, and it was talking about how what is the most expensive thing in building data centers or in maintaining data centers. And what they say basically is that 40% of the maintaining costs are only for the cooling of the hardware. Yeah. And the reason why is you need to maintain the whole thing in a temperature that is like underneath 20 degrees Celsius or something like this, yeah. Which you can take up, but it's at your own risk. What is it for you? Is there like a tolerance for?
I don't have a number in mind, but I think it's really within that range. You don't really have to. I think we rarely have an issue with the cooling our hardware, because literally they don't generate as much compared to other hardware. We are very. This is why I told you, for example, right now our customers Argyle. They have a very specific requirement. They're using renewable energy to power their data centers. Of course, they are in UK and Scotland, and maybe they have to. They have like maybe the climate is helping, but the idea is like a lot of these companies, they are also operating GPUs, but if you cannot actually rely on renewable energy to power those GPUs. And the more power you need, also the more cooling you need as well. But for us, just using the renewable energy, it's really a good story for us that not only we don't consume a lot of energy, but also you don't have to really worry about cooling our hardware, because it's very nice and calm.
Oh, that's very cool. So if we talk about Europe, for example, where I think the sovereignty over the data, namely with all the regulations and GDPR and all of that stuff, is something that matters the most for the governments here. Do you see that you have like a leverage over the other competitors in here?
Yeah. Exactly. So I think the thing that our customers in Europe, I think for us as a hardware, we really make that actually easy to comply with those regulations. So yeah, so in terms of GDPR, it's something like not a big problem for us. So our customers are compliant with GDPR, and they are using our hardware, and really they don't have to worry about any of that. So, and also we have a lot of certifications in terms of privacy, etc., that really make things a lot more streamlined, basically, in this sense.
Okay, and who are your competitors? We have NVIDIA basically, and what are the others?
I think the other competitors are basically Grok and Airbus for the time being, and I think these competitors, they are capable to provide really impressive speed. But the question that nobody asks is like how many hardware you need to be able to get
what
that
cost. Yeah.
So for these competitors, they are the hardware is something that we call SRAM only architecture, meaning they don't rely on multiple memories like HBM, DDR, and the SRAM to be able to map the model and to do the calculation. They only rely on only a fast and very fast and fast and a very lightweight memory called the SRAM. And the SRAM is known for two things. Like, it's very high in speed, but also it's very expensive and very prone to failure. Like, because the transistor in those memories are very susceptible to fail for any reasons. So you have basically here two risks. So the memory is small, so you need more hardware to be able to fit in, let's say, large models like DeepSeek, which is 1.5 terabyte. And we are talking about SRAM. We're talking about like maximum how much? Like 500 megabyte, 1 gigabyte. So if you have like a model of 1.5 terabyte of DeepSeek, you can imagine, you can do the calculation how many servers you need to be able to support that. And this is not a surprise, because if you check their platform, they are actually not supporting DeepSeek, for example, because it's just a huge models and it doesn't make any sense for them to be able to make that available to their customers. So the idea for them, while they can do a very high speed, they are really having a hard time being very efficient from a sovereignty and hardware perspective. The hardware is not optimized, the energy is very high, the footprint is higher as well. So we're talking about like 20 or maybe 10 racks to be able to do the job of one rack of SambaNova. It's even more inefficient than NVIDIA. So that's why I'm telling you, like, SambaNova is really in the sweet spot. So we are staying in competitive to NVIDIA performance and speed, but also at the same time we're really optimizing the hardware you need to deploy in order to get that speed for you.
No, that's interesting. I don't know if you have seen it, but there is like a very small GPU that NVIDIA sells for the geek people. And it costs like 3K or 4K. So I don't know if I've seen that. Do you have like something similar for somebody who is geek and want to explore the type of your type of solution? Or
definitely this is something that we're planning to do. But for now, we are really focusing on making this available for enterprise, because this is where really having huge issues. A lot of banks, they want to use DeepSeek, they want to use Whisper to basically transcribe those call center calls or even meetings, etc. But they cannot actually share it with anyone, because they cannot use this AI, because it's just so sensitive for them. So we're trying to make this possible for a lot of banks, a lot of government entities, and a lot of other enterprises, that they can support their infrastructure, run those models. You don't need a crazy number of hardware to be able to do all these numbers. So we're really focused on this. Of course, this is something in the roadmap to make it available for developer geeks and nerds. But for us right now, it's not something we can promise in the future. But
yeah, it's basically like asking the question: who gets to decide what cloud should the company go for? Somebody would say it's the stakeholders, it's the CEOs, and somebody would argue that it's the small or the developers who are at the bottom of the chain.
Exactly. Look, this is exactly why we are actually doing the cloud, because we want to reach out to developers, connect with them, and we're really doing a lot of
makes sense.
So let me tell you this. Like, this week we announced a hackathon with Hugging Face, and we're doing it only for developers. It's not something, we're not just close it and focus on the enterprise. While enterprise buy the hardware, we make it actually easy for developers and startup to actually use our cloud. So we have some subscription models. You can commit to a certain amount of spend. We have also pay as you go. And if you just go and sign up, you get $5 free. $5, you'll be able to do a lot of things with it. But you can do pay as you go. You can just add your credit card and go ahead and just start using those LLMs, no restriction. If you want to have higher rate limit, developers, they can commit, or startup founders, they can commit to a few K. I think if you go to other provider, they will ask you at least for 100K. We really don't do that. We actually really, it's very small amount to spend annually. And you can commit to that. You'll be able to get higher rate limit. And that's exactly it. So we want to make this available.
Is that the same thing that Hugging Face provides? Like,
you can actually use SambaNova through Hugging Face, but it's very similar. Yeah. So I don't know which package you're talking about for Hugging Face.
I don't remember exactly what is it called, but basically that the possibility to inference any model.
Yeah, I think Hugging Face provide you with the rental for the hardware. We don't do rental. We do dedicated instance rental, which
How
is
is that different?
because you're renting the whole server. You're not just renting one GPU or two,
Oh, I
etc.
see. So it's
So,
not virtualized. It's basically a
it's
unit of hardware. Yeah.
exactly. So it's 16 chip at a time. But actually, we're making this much simpler for you. You don't have to worry about how many GPUs you want or how many RDUs. You just commit to a certain rate limit you're looking for, and we'll just make it available for you through a subscription model. And as I told you, like if our as you said, like who decide the stakeholders, etc. From business, actually, we just not too much focused, at least for now, a lot on the
What do you see yourself as a business or as a developer?
well, actually, I mean, I'm still a
Somewhere
developer.
in the
Like,
middle.
while and by day I am a business, but and at night I just take my laptop and just keep coding. So I'm a developer by heart, even with my fancy shirt. But I'm really a developer.
I'm not
I
wearing
think
I'm a fancy shirt, so I'm on the other side of the equation.
so.
Yeah,
Yeah,
keep going.
but the idea is the cloud is really where we're trying to support developers, and we're doing a lot of things in our documentation. We're really focused on working with open source tools like Light LLM, Daytona, a lot of this LangChain, Llama Index, all this integrations to be able to support exactly the developers. Because for us, we want to make it easy for developers to use to get access to high speed performance without worrying about any other other aspect. Like they don't have to worry about orchestrating the LLMs working together. They don't have to worry about all of these things. Just focus on building their own and enjoy their application layers.
Perfect. So now, if I go back to my train of thought, I have trained my model, and I have done my development side. I was an AI engineer, and now I talked with you. We agreed on a price, and now you provided me with a GPU, and I deployed my model. What happens after this? Is it like a support that you provide, and
Of
what is
course.
like? And what I want to touch upon is like your presence. Is it physical? Is it do you have how are you like spread around the world? Do you have like for every continent a physical unit there, or how does that go?
Yeah, we actually offer both type of support. We have actually the in person. So we have different type of SLAs. So on cloud, we actually have a dedicated team for support. So we have our paying customers for the cloud, enterprise actually customers who are just opting for the cloud, and they are getting like really almost immediate support in terms of like if they got anything. And also for our hardware, for like sovereign AI, we have like SLAs, like we're talking about 24 hours, 12 hours, etc. And it's something we do it in person for sure. So that's
cool.
yeah.
And so for somebody who does not know your company and who does not know even what NVIDIA is, what you said is actually amazing and would convince anybody or who is interested in the technology or in deploying technology to go ahead and sign a contract with you and start the deployment. What is the thing that I'm not seeing here? What is the challenge? What is the dark side or the harsh side that I'm not seeing in this
Look,
amazement that
yeah, I think there's no dark. I think what people should understand is the semiconductor industry is really intense one, and it's not like because you are technically competent doesn't mean you should get the job. Like if I can make it a simple way, there are a lot of for example,
explain that point. It's very interesting.
so let's imagine you are like I'm oversimplifying this, but it's
Like you.
because yeah. So if you are like a very competent engineers, like there are other aspects why people will make decision to hire. So the same thing for SambaNova. First of all, I think we did not invest a lot. We're really focused a lot on R&D to develop and make sure perfection our chip. And I think it's only like right now a few months, maybe almost now 2 years, that we really started aggressively going into the market of enterprise, etc. And by the way, we are the most deployed startup in the U.S. Department of State, like in the U.S. government. And this really where like was one of our revenue stream, etc. And we didn't really focus a lot on trying to be very known, because really wanted to focus on our chip. So now we get really try to be more open to the market. You can find us in Australia. We just closed a huge data center in Australia. We just closed another one in Europe, and also Aramco is like a long-standing.
What is it based in Europe? Just for the curious people.
Germany.
Germany.
So
Okay.
Germany. So we have it in Germany. We will soon have something in France, and we will also have something in UK, and also in the northern region.
And I have also heard that you've raised like $1 billion.
Yeah, we raised.
Did you burn it already, or not yet?
Yeah, look, I think because the company did not close, I think two things. Our revenues are not only coming from the funding, but actually it's coming from the sales we make. And 2025 is a wild year for us, and I think 2026. This is what brings me to your point why we are not known. I think right now. There was a moment we were actually ahead of the market. So actually the market was actually not aware about the importance of the energy, the importance of the sovereignty, etc. But only in late 2027, 2025, people start talking about sovereign AI. And
I think I'm going to cut you here. I think there's also the component that we were only talking about the training of the models.
Exactly.
We're not talking about the inference that would consume the most of the energy that's doing it.
But we reached the level of LLMs that's actually smart enough. Like people stop talking about training the LLMs and start now talking about the inference and how we can use those LLMs, etc. And this is where really the inference discussion becomes a big question mark for a lot of companies. Okay, I want to use those LLMs, but I cannot actually use them for a public API. I need to make it sovereign. And this is where I'm telling you, like, all of a sudden, even for us, like a lot of companies really coming to us. Hi, I like SambaNova. I want to go ahead and do the transaction, and also do a lot of partnership with you, etc. This is why I'm telling you, like 2025 is really a huge year for us. But I actually have like really strong feeling that 2026 is actually going to be a wild, like already 25 is wild year for us, but 2026 is going to be even bigger.
How are you going to manage this, knowing that you have like a limited bottleneck, which is the SMC, the provider of the chips?
Yeah, but I think this is not on us. I think for other hardware providers, they have issue with the supply chain, and I think for us, we're not having this issue. This is what I'm telling you, like for the delivery and time. So there is something in business called time to value. Like today, you're paying or making your investment on infrastructure. Maybe you have to wait 1 year or 2 years before you see that actually comes to life. I think for us, the time to value is a record time. We actually do it in 3 months. So. And this tells you a lot. We don't have an issue in supply chain. We don't have an issue.
And how are you able to achieve that? Are you paying more, or do you have like?
No, it's simply because just our the way how we are packaging our system, it just make it easy to get integrated.
I did not understand that one.
Let me tell you this. I'm happy to tell you this in more details. So let's say you buy NVIDIA today. Okay.
Yeah.
As I told you, you have to wait for it to be delivered. If you're lucky, you can get it in 3 months. If you are very like an average Joe, maybe you have to wait 6 or 8 months before you get it done. Actually, deliver it to your data center. That's one.
Okay.
That's one. Assuming you have the energy supply necessary to be able to operate that, because it's very important. And maybe you need at least 20 kilowatts. Let's say 15 kilowatts. Just for the power supply. The energy consumption can be very different. I'm gonna go with the simple case. I'm not gonna tell you about the Blackwell that will require you for liquid cooling and etc. But let's say H100. So now you have to wait for the H100 to come in. The second thing is you need to bring the team who's actually capable to handle the GPUs. So if you are aware, like the GPUs, you have to put a lot, like an abstraction layer, which is a bunch of Kubernetes who are actually implementing the LLMs. Of course, the LLMs, you need to basically, first of all, to be able to handle them, like how many LLMs you want to deploy. I'm not sure how rich you are, but like as a company, but it depends how many hardwares you want to do. So you need to figure out a lot of things. How am I going to do in the load balancing? How am I going to do the orchestration? How am I going to do in the operating system, etc. And all of this, you have to manage them before you get to the application or the inference layer. So you have a lot of technical roadblocks, and this is not going to be done by itself. You need a whole team, a dedicated team who is actually very expert to know how to manage all of this. You need hardware team, you need infrastructure team, you need LLM machine learning engineers to be able to handle the optimization and of the inferencing. So yeah, so it's a whole dedicated team to be able to get this done.
So if I wanted to be SU and say basically that I'm a platform engineer, I'm used to deploying Kubernetes and used to deploying the whole infrastructure on premise, and I'm able to do what you have described. How are you going to challenge me? Is there a specific knowledge that I need, or
no? Actually, it's good for me if you are actually expert. Is like if you have the team already, you'll be able to scale much faster with SambaNova, because for us it's only you do it only once and you just keep adding the rack, and it's linear scaling, like you just doubling your performance. If you want to do the same thing with NVIDIA, it's not actually the case, because it's sublinear, like meaning it's not linear, it's like way less than that. And also the bigger the hardware, like a lot of like one person is not going to be enough. You need like actually multiple people. So really the scaling the sovereign AI is really where we make really a huge difference compared to NVIDIA. And this is why you see right now our customers, they are like AI providers at scale, like SCX, which is a AI data center in Australia. It's actually offering the global south. It's trying to like really be able to provide the AI services for this part of the world. And this is where really SambaNova really shine as a technology.
Yes. So I believe you have exchanged with the teams of your clients, and you basically meet all the mindsets and the trades of work in that field. If I asked you, for example, if you have to describe something that needs to be in the team that would manage this infrastructure, do you think that, for example, if I have a team in place that already manages my infrastructure on premise, they are very proficient in Kubernetes, they are proficient in all the technologies that are needed for legacy data center or normal data center. If we added the GPU, is there like something special that they need to learn, and how much time this is going to take for them to scale up and be able to monitor that or be able to manage that?
Look, I think this is a good point. I think the idea is how critical is your service to your customers? Like, are you optimizing for speed? Are you optimizing for scalability, etc.? Because if you are optimizing for speed, or if you are actually optimizing for all of these, you need to be able to know how to really optimize your orchestration layer in a very specific way, etc. So I think I don't know how to answer your question. Maybe ask your like maybe to answer by in SambaNova instead of NVIDIA. But the idea is
the idea is like, do you have like a special consultant that do the job, or is it just anybody who?
No. Actually, it's any engineers basically. But I think the idea for SambaNova is you don't have to really worry about any of this. It's actually self-managed, and you don't really have to worry about any of this. The only thing you worry about is which model you want to serve and what awesome AI applications you want to build. I think for the orchestrations and everything else, like all of this is actually managed by the SambaNova team, and we do a regular support and update for the software, and just don't worry about it. It's basically it.
Yeah, so I've been worked with a lot of software providers who would provide you basically with this abstraction layer. I believe that I'm not the only one who had a bad experience with this, because basically what happens is when they give you this abstraction layer, there's all the thing that comes with it, which are the problems. And basically, when you install the software and you have this abstraction layer, it's all fun until it breaks, and then the problem starts.
Look, I think first of all, We deal with like a cloud architect, or basically someone expert in Kubernetes and containerization. But I think when something break, as part of our SambaNova mindset is like we're really always there for our customers to be able to support them. So we are documenting, we're providing the right documentation, we have actually a dedicated team to do the support, etc. And our purpose is that you'll be able to run this business on a large scale without actually worrying about this, without worrying
That's
about something to break, basically.
oh, that's amazing. If I wanted to ask you, what is the minimum engagement in terms of money and?
Look, I think
I mean, you don't have to answer this for SambaNova, but just in general, do you have any numbers, for example, for NVIDIA, any other compares?
look, I
Is
think
there like if you want to, for example, I'm asking this because if I'm a startup and I have like a limited budget, what is exactly should I just go for the cloud because it's the cheapest one and I can control my pricing and then I can basically back this up later on with the sales that I will be making, or should I already think about the on-prem solutions because they are affordable?
Yeah, actually, very good question. Look, I think the good news is, like always, the cloud is the cheapest way because it's like lower
Is
engagement.
it cheapest short term or long term?
So this is it. So if you are a startup who want to build something, of course it's cheaper for you to go for the cloud until you really confirm the need or justify the need to go for something much more expensive. Of course, if you are doing something on-prem, it's going to be much more affordable and much more economical on the long run. And I think if I would say for developers and builders, I would go actually for cloud, because if, let's say, if you want to go for NVIDIA, if you want to go with NVIDIA, you want to do like let's say 2 LLMs, like high caliber LLMs like DeepSeek and Llama, Maverick, etc. Let's say you will need at least 2 nodes of H100, H200, and we're talking about, like, I think for NVIDIA it's like around $1.5 million to be able to do that.
Okay.
So I think, and here I'm speaking like at least the minimum cost to own, because the rack themselves, they cost $500,000. And if you want to buy 2 nodes and also plus these
is it the racks without the chips, or can you just define the terms?
It is the rack, of course, with the chip, but you have to install it. And some here, if you want to do on-prem, you have to really host it, and you have to pay the data center host to be able to run those nodes for you, etc.
I cannot host it on my let's say my building.
No, it's actually first two things. It's very like loud and noisy, because the sound's gonna make it really high, and you need a really good environment for this. But in case you really manage to do it in your building, also the power supply, it's gonna be problematic, I think, for this type of servers.
But that's very interesting.
But I think, but again, as I said, like if we are talking about Blackwell, it's not like we're talking about like V100. Of course, V100, you'll be able to do it in your own building, but it's always recommended. I'm not an NVIDIA expert, but I think for this level of order of magnitude of computing, it's always good to have at least a mini or the right place for you to host your data centers, in terms of networking, in terms of power, and also in terms of other management costs that will come with it.
I have seen that in your profile that you are building data centers. You mentioned it on your bio. I have an interesting question for you. Is anybody able to build the data centers and resell the service, basically?
Exactly. Yeah, go ahead. Sorry.
Yeah, and I was going to ask about the regulations, the fees, and what is the process exactly? Did you have to do something with the government? Who intervenes in those kind of projects?
So basically, our customers who want to build a data center and they are looking for the best, basically, option in terms of scalability and cost to own and cost to operate, from hardware perspective, they comes to us and we help them build the infrastructure for it. So they handle the real estate, and they handle all like the power and everything.
Engineering that comes with it.
Yeah, exactly. So the building and the facilities, it's something they own, and I think it's another business, basically, literally another business with a lot of regulations, as you said, with a lot of security certifications, etc. But since they actually handle all of that, it's including GDPR regulations, etc. We just comes in as a hardware provider. We install our hardware and make them actually resell that capacity to their customers.
So basically, to start having a conversation with someone who wants to build a data center, they should already have their paperwork done, and they should already have built the facility that would
presumably. Yeah,
okay.
presumably.
That's interesting. Do you have like any given your experience with all those models and the clients that you have today, do you see any pattern on the adoption of those models, and what by industry? Let's say, for example, for the banking industry, what is the tendency in terms of models? What model they go with? What are the constraints, etc.?
Yeah, good question. I think what I see is there's a very interesting case for voice use cases. Like a lot of people, they have, let's say, call center. Call center can be something really, really interesting for a lot of, and it's going to be also very sensitive. So being able to support like speech to text models like Whisper is something really interesting. What's nice about SambaNova is we can run really Whisper with a high speed up factor. Like we really can transcribe like 3 hours podcast in a couple of seconds and even a minute, and this really gives you the chance to build a copilot for call centers. So to answer your question is, yeah, Whisper or similar models. We also see a lot of OCR use cases, like let's say using Llama Maverick as a model to be able to process like some old document that due to the legacy of the data infrastructure you have a lot of scanned documents. So you're looking for an LLM that will help you to parse those documents you have. So of course, Llama Maverick, DeepSeek for coding. So if you have a lot of a big team of coders, you don't want them to send the code to OpenAI or send it to some of these providers. You want to keep it as private as possible. So a lot of customers, they're actually asking for coding LLMs for that.
So basically, you're saying that nobody deploys the OpenAI open source one. That's a trap.
Yeah, actually, it's part of it. We actually support it, by the way. Just for information, it's part of our cloud, and it's actually a very trending model as well. But for me, I focused mostly on the use cases and the type of LLMs rather than trying to name names. But of course, GPT-OSS is really one of the trending LLMs we have, and we see actually being used by our users.
That's interesting. We've learned a lot of things today. I think we've taken 1 hour and a half from your time. Do you feel that you missed something that you wanted to say, or do you feel that there is something?
No, thank you so much. Really appreciate it. I think Europe is really going to be like a very interesting arena for this AI business, and I think it's there's a lot of exciting things to come. As I told you, we just announced a couple of exciting things, and there are a lot more coming. So looking forward, maybe we can connect in a year from now, and we can discuss about the exciting stuff we can do, not only in Europe but also around the world. So,
and it should be a physical meeting next time, correct?
Sure, we'll do it as a physical meeting for sure.
Thank you very much, Soufian, for your precious time and all the information that you have shared today. I don't believe that we have any comments today. Thank you for anyone who tuned in and watched the eAfterWork, and we are looking forward for more podcasts. Thank you very much. Thank you, Soufian. A good one. All right.